Whether you know it as Newton's Cradle or the executive ball clicker, chances are you've seen the educational desk toy. The device consists of a row of 5 or more balls. They are hung from a crossbar by wire, with the balls at the points of an inverted triangle. This guarantees that the balls can only swing in one plane, parallel to the crossbars. All the balls are exactly the same size, weight, mass, and density. The impact of one ball will do the same amount of work on the second ball as gravity did on the first one. The balls must be perfectly aligned at the center to make the cradle work the best. It demonstrates some of the most fundamental laws of physics, like conservation of energy, conservation of momentum, and friction. The principle of conservation of momentum states that when two objects collide, the total momentum of the object before the collision is equal to the total momentum of the object after the collision. In other words, when the first ball collides with the second, the first ball stops. But its momentum isn't lost, just transferred to the second ball, and so on. So if you hold two balls in the air and then release them, then that energy is transferred to the two balls on the other side of the device. Now, why do the balls come to a stop? This is because of elastic collisions, which occur when two objects run into each other, and the combined kinetic energy of the objects is the same before and after the collision. However, that's the perfect Newton's cradle. In a real-life situation, the collision is in reality an inelastic collision where the kinetic energy after the collision is less than before the collision because friction will always plot to slow things to a stop. The balls are not elastic, so they cannot escape the effect of friction, but the total amount of energy stays the same due to the conservation of energy, which states that energy can't be created or destroyed, but that it can change forms. It shows potential energy from one ball being converted into kinetic energy once you let it go, and that energy is transferred to the rest of the balls, which then results in the swinging of the balls of the opposite side of the cradle. As the balls are compressed and return to their original shape, the friction between the molecules inside the balls converts the kinetic energy into heat energy. The balls also vibrate, which vanishes energy into the air, creating the clicking sound we hear.